Morning, everyone. Uh, my name Arief Budiman Darwin. I will present the course assignment from the subject of the technical textile from the lecture of Mr. Hendra. This is for the master degree of the textile and apparel engineering. I will present the journal, the title of the physical mechanical properties of automotive textile materials, uh, made by Ivana Gudlin Schwartz, Stana Kovacevic, and Ivana Kos. This journal is taken from the Sage journal. The role of the automotive textile materials is one of the great importance. Therefore, this paper is to analyze the properties of the textile automotive material, such as airbags fabric and upholstery fabrics. The fundamental characteristic and construction parameters of the airbag fabrics and artificial leather with the bonded textile fabric on the backside, as well as joining or sewing, and quality of joining places of cut parts are crucial for durability, comfort, and aesthetic of the automotive interior design. For the airbag fabric, specificity and the extreme values of the several parameters are extremely high densities in warp and weft direction, a great strength, and then also the air permeability properties of a very low level. The most important parameters for the upholstery fabric or artificial leather durability is breaking force and elongation at break. They were tested in different circular directions. The tests show the direction with the greater braking properties, what is of the paramount importance. For the airbag fabrics belongs to the group of the technical textiles, and they are designed for the passenger safety. Their specificity and extreme values of parameter class them as the fabric which are manufactured with the most demanding manufacturing processes from the fibers to the finished fabric. Their feature is the high warp and weft density as well as the fabric strength. The first airbag was introduced in late 1960s until 1980s was used as the driver airbag. Passenger airbag was introduced in 1988. And then side airbag was introduced in 1994, and then later the curtain airbags were introduced in 1998. As the consequences of the car development, motor vehicle airbags become more numerous and effective. This places increasing demands on fabric production, cutting, sewing, and joining the most suitable shape of the airbag. Woven airbag fabric is made exclusively from synthetic, which is polyamide or polyesters, with a highly strong multifilament yarn with the very high fineness. To weave this kind of fabrics, special equipped weaving machines are required. Rigid rapier or projectile are used for weft insertion, and fabric are woven on camloom in plain weave with extremely great densities in both warp and weft direction. It is necessary to pay attention to the fabric folds and avoid the break points of warp and weft, as well as to the direction of the lying and joining sewing card, because the airbag safety depends on it. Even on the latest jacquard technology enables what they call the OPW, which means one piece woven airbags that can take a multitude of shapes and be used for many different purposes. For the airbag fabrics, each breakage or damage of material may cause serious consequences, such as insufficiently inflated airbag or untimely gas deflation, and also the gas poisoning from the airbag itself. The air permeability should be at a very low level that is achieved by weaving frequently with a synthetic coat on the backside of a fabric that is applied in chemical finishing. It is necessary to pay attention to the fabric folds and avoid breakpoints of warp and weft, as well as to the direction of lying and joining for saving cut parts, because the airbag safety depend on it. Now we're going to talk about the upholstery fabric. Uh, Here specifically, we're talking about the artificial leather with the bonded textile fabric on the backside. Besides the passenger safety in the motor vehicles, drive comfort is very important. It is a sector the textile fabric play a significant role too. In addition to the ergonomical design, car seats keeping the body in correct sitting position, it is also essential that the passenger feels no bodily fatigue due to the sitting discomfort. Pleasant contact between the body and seats depend on the upholstered section that is mostly composed of non-woven, woven or knit fabric and artificial leather. The non-woven material lies in the interior of the seat and it's used for lining solid metal, wooden or plastic car components. The fabric that contacts with the body should have a good aesthetic and good strength, toughness, and abrasion resistance for the lifetime of the car. Artificial leather has all attributes of the natural leather, plus the added advantage that the additional properties may be engineered into the fabric. Upholstery fabric is compound textile material whose stability can be improved by the laminating woven or knit fabrics to the backside of artificial leather, which is obtained by the thermal joining. Thermal joining of the woven or knit fabric and polyurethane foam is carried out by the coating a thin adhesive film, which under the high temperature binds the surface together tightly. On the picture on the right side, this is the illustration how is the bonding is happening. The fabric used for the back of artificial leather is a cotton fabric in most cases, which has been woven from a single ply yarn. The yarn is warped on the warping machine, afterwards sized and woven on the air-jet weaving machines in plain weave. After the weaving, the fabric is inspected and false remaining thread and fly lines are eliminated. But in most cases, it is not chemically treated. Fabric heat setting is carried out in this process of artificial leather manufacture. The woven fabric imparts higher stability and strength to the artificial leather, and the knit fabric in this case is warp knit fabric made of bright cotton yarns imparts for the higher elasticity. Artificial leathers supplemented with the woven or knit fabric gain the strength, durability, and elasticity so that these fabric combinations are used for all application of artificial leather. Between artificial leather and woven or knit fabric, polyurethane foam is bonded to obtain the softness and the flexibility of material. Sewing car seat covers required special sewing machines adjusted for sewing multi-layered thick materials, as well as the special sewing needles to join cut parts without damaging the cover and the thread. The selection of the correct seam is particularly important in making car seat covers, as the seam must meet regulatory standards ASTM D6193. Beside the seam, textile material and needles are influence factors for the seam quality. So the aim of this research, first, to show the impact of construction parameters on material properties, which is airbag and upholstery fabric, relevant to their specific applications, as well as their differences. Uh, Second is the compare two groups of upholstery fabric with non-woven and knit fabric on the backside with similar characteristic, mass per unit area and thickness. And then the third is the research emphasize testing breaking properties in different direction in order to show the material direction with the greatest strength, which is of great importance when laying cut parts to construct the car seat covers in order to achieve maximum durability when applying stress in use. And then four is to show the impact of the joining place on the seam area on the material breaking properties, taking into consideration that this is exactly the weakest place of the car seat cover. The experimental materials and method. For the purpose of this research, two sets of textile materials were selected. For airbag fabric, there is two sample, which is sample 1 and 2. And for upholstery fabric, there is two samples also. One is the artificial leather with the woven fabric on the back side. They also have two samples, which is samples 3 and 4. And then another fabrics, the leather, artificial leather with the knit fabric on the back side, which is the samples 5 and 6. For the upholstery fabric is a compound material produced by laminating process and consists of three layers, which is the artificial leather itself, and then the PU foam, and then the knit fabric. The construction parameter of the tested fabric are shown in the table 1. Okay, this is the table 1. We can see the construction parameters of each sample for both airbag fabric and also the upholstery artificial leather fabric. For the airbag fabric, we can see on the sample 1 and sample 2, they are making from a different construction, different densities. The samples is been made from the polyamide fiber, polyamide 66 or nylon 66 with the plain width. And then for the upholstery fabric, there is two samples, artificial leather with the woven on the back side, and then artificial leather with the knit on the back side. They are also construct from a different construction on both woven and knit. For the artificial leather with the woven fabric, this is using the cotton woven fabric, while on the artificial leather with knit fabric, using the polyacrylic knit fabric. The other equipment that we are using on this trial is the sewing machine. It's a special PAF 1427. This is the high-speed sewing machine. And then for the breaking force of the sewing thread, it's also tested on the Statimat M tensile tester. according to the ISO 2062 standard, and the twist level was tested on the mesh done twist tester. Saving thread fineness was tested by winding 50 by 30 meters on the reel and then weighing on the electronic analytical balance. The samples were seen in the direction of zero, meaning that to the wave or course direction. And there are also tensile testers from the Apparency Branca for testing the braking properties, force and elongation at brake, according to the STM D1682. And also there is a ball bursting strength resistant for airbag and upholstery fabric will be tested according to the STM D3787. And then the air permeability of the fabric will be tested by the SDL ACHAS instrument according to the EN ISO 9237 standard. And for the open porosity or the open area, which describe the fraction of the macro pores of the cross-section area of the fabric, which will be directly influenced to the fabric air permeability is calculated as follow equation. So the open porosity will be calculated from the macro pores cross-sectional area divided by macro pores sectional area itself plus the projection area of the warp and weft yarn equals to the 1 macro pores in millimeter square. P is the yarn spacing in millimeters, and then D is the yarn diameters. There are two yarn diameters in the case for the warp and weft respectively. For the testing braking properties, sampling of upholstery fabric, which is the artificial leathers with the polyurethane foam and woven and knit fabric on the backside, was performed in the differential radial directions in 6 various directions with the difference of 30 degree. So it's starting from 0 degree, 30 degree, 60 degree, 90, 120, 150, and then back again to the 180 degree. The reason for that kind of testing is to show the material direction with the higher braking properties, which is of the paramount importance when aligning and joining the cut parts. Now we're going to talk about the result and the discussion. Due to the division of the tested materials into the three groups, sorry, by the three structural differences on the basis of constructional parameters from the table 1, the statistical analysis was performed, F and T test with statistical reliability of 95%. The objective of the analysis was to determine whether there is a statistically significant difference between samples of certain group, airbag fabric, sample 1 and 2, and upholstery fabric, sample 3, 4, 5, and 6, with regard to the influential parameters, mass per unit area, and thickness. Based on these values, it can be concluded that between samples of the certain groups is a statistically significant difference, and they need to be mutually compared just to show a significant influence of minimal constructional differences on the relevant material properties. Now, the we're talking about the breaking forces of both airbag fabric samples are higher in average of 19%. Then in the direction of 90 degree, which is to the warp direction, then the 0 degree, which is the wave direction. This is due to the higher thread density in the direction of the 90 degree instead of the for the warp direction. Higher density in the specific direction of the samples result in the higher breaking force in that direction, sample 1 in wave direction and sample 2 in warp direction, in addition to the highest breaking force. Sample 2 tested in the direction of 90 degree to the warp direction also show the highest elongation break, which is 23% higher than the elongation of the sample 1 tested at the same direction. As we can see um, on the 90 degree, the elongation at break of the samples is the 1943, while on the 0 direction, sample 2 is 1422. Um, so these differences may be caused by the difference of the weaving machine and the different warp densities, where at the higher densities, lower tension and dynamic stress occur, and thus lower yarn deformation than at the lower warp densities, resulting in a greater elongation and tensile force. The samples of the upholstery fabric, the artificial leather with the woven fabric at the backside, which is the sample 3 and 4, and then the artificial leather with the knit fabric on the backside, sample 5 and 6, differ in the breaking properties. We can see the comparison at the table 3, at the figure 3, this one. And the highest breaking force of all tested samples shows the one tested in direction 90 degree, which is the warp or whale direction. As we can see, the highest numbers, which is on the 90 degree direction, compared to the 0 degree, 90 degree direction is still higher, about the 20% on the sample 3, and then about 15% for the sample 4. And this difference is lower at the artificial leather with knit fabric on the back side, which is 5% for the sample 5 and then 10% for the sample 6. Yeah, this one. So the backside of using the knit fabric is lower than the backside using the woven fabric. On the other hand, all other sample tested in the remaining direction show significantly lower breaking force compared to the 90-degree direction. For the sample 3, in average is 53% lower, and sample 4 is show 48% lower. All the sample tested in the direction of the 90-degree warp or well direction. Uh, Here we can see the show the lowest value of the elongation in the range of 14.9% to 17%, while the highest elongation record the samples tested in direction of the 150-degree. So we can see the 90-degree is the lowest, while the highest is the 150-degree. The reason for the lowest value of elongation at break in the 90-degree direction of tested sample of artificial leather with woven fabric on the backside result from the weaving process, where the presence of the highest stress in the warp direction causes a major deformation of warp threads. Also, the reason for the highest elongation in direction of 150-degree or 30-degree can be found in the weave with the maximum number of interlacing warp and weft thread and extreme or winding around, which is the result is greatest yarn shrinkage in the fabric, which is creating the thread reserve, which allow maximum fabric flexibility and elongation in the specified direction. Now we're going to talk about the breaking properties of the samples with the seam. So the seam direction of the 0-degree, which is to the weft or coast direction, uh, were tested in the 90-degree direction to the warp or well direction, which is also to the direction of the seamless samples with the greatest breaking force in order to implement the comparison. So we compare the fabric with the seams and then the fabric without the seams. The breaking force of the seam samples of artificial leather with woven fabric at the back side, which is the samples 3 and 4, uh, are on the average lower than the seamless samples for almost 17%, and as well as elongation at break in average 8%. Samples of artificial leather with knit fabric on the back side, samples 5 and 6, show even larger variation. Uh, it shows that the reduction of breaking properties where the seam samples have average 20% lower breaking force and even 20% lower elongation at break than the seamless samples. This is the reason why that the seam should be avoided in the areas of the car seat covers with the presence of the high stress in the application. So, considering that the influential parameter for the result of a ball bursting test for the airbag fabric are mass per unit area, thickness, width, and therefore the fabric open porosity, the parameters of bursting parameters as are consequently. Despite the greater mass per unit area and lower porosity of sample 2, sample 1 has a slightly better bursting properties, which is the braking force and elongation at break, as we can see at the chart on at the right side, which can be explained with the better balanced distribution of warp and wave density of the sample 1. Small differences between sample 1 and 2 are statistically significant as the evidence by p-value for the braking force and for the elongation at break. The variation of measurement values are relatively small by standard deviation and coefficient of variation. And the reason for this uniformity of density and fineness, which is distinguishes synthetic multifilament threads. According to the test result, it is evident that the sample of the artificial leather with the smaller mass per unit area and then the smaller thickness, which is a sample 4 and 6, have a slightly better bursting properties than the other one, which is sample 3 and 5. The reason for this occurrence could be found in the material properties, where during the ball bursting test in a very small area, tension equal and fabric elasticity comes to the fore, i.e. their extension properties, which also influence the higher braking force. Sample of artificial leather with woven fabric on the backside, which is sample 3 and 4, have on average 8% higher braking force than the ones with the knit fabric on the backside, which is sample 4 and 5. Which is at the same time have on average 23% higher elongation at break. Those differences were also statistically tested and thus proved to be statistically significant. We come to the conclusion from this research. According to the obtained result, it can be concluded that the small difference in the constructional and production parameters of the fabrics are significant and influential for their properties. The minimal differences in airbag fabric construction, thread density of warp and weft greatly affect braking properties, as well as fabric porosity and thus the fabric air permeability, which is a property of paramount importance for the airbag fabrics. Structural parameters of the component material and constructional parameters of woven or knit fabric on the backside influence and make a big difference in their properties. The highest strength of both type of component material are in the direction of 0 and 90 degree, where the samples of artificial leather with woven fabric on the backside proceed. Concurrently, material strength in all the decisions in generally greater on the samples of artificial leather with the knit fabric on the backside. Great reduction of breaking properties occur by saving materials, and this phenomenon was particularly pronounced in the sample of artificial leather with the knit fabric on the backside. All mentioned indicators are extremely important for process of cutting, lying of cut parts, which have to be placed if it's impossible in the direction of materials, greater strength, direction of 90 degree, which is the warp or well direction, and which needs to be pointed in the direction of the highest stress of the car seat cover in actual use to providing a greater durability and stability. So that's all the summary from this paper. Hopefully, you all can take some information from this paper. Thank you very much.